All right, in this video, we're going to go ahead and take a look at particle motion, and it is an important concept for calculus. And so we're just going to be introducing it and applying what we know about physics and technology and pre-calculus to go ahead and make rewarding arguments for some of the questions that are asked of us. So, by the end of the lesson, I'll be able to answer the following questions. How do I solve particle motion problems as they relate to physics and calculus? What are the physics properties related to particle motion problems? So there's four things that we're going to take a look at that are going to be really important moving forward. First of all, the position of a particular particle, and that is going to be referred to as SFT, where it is position with respect to time. Velocity, the change in position with respect to time, it's directional, and it's represented as V of t. And the change in velocity with respect to time, and it is directional, is represented as A of t. And then speed is going to be the absolute value of velocity and is not directional. So for those folks that have had physics in the past, this, you're going to be a leg up on everybody else. But you don't need to know physics exactly to go ahead and solve these problems, so don't worry. One of the things that is going to be monumental to solving these problems is whether or not the particle is speeding up or slowing down. And so acceleration and velocity, if they have the same sign, then that particle is going to be speeding up. And if the particle is slowing down, then acceleration and velocity have different signs. And so that's just all part of the physics play, and I'm going to introduce those and elaborate on those in a better way when we get to the examples. So let's go ahead and jump into an example and see how to set these things up and how to be successful with particle motion. All right, here's our first example, and there are some things that I want to go ahead and set up before we actually get to solving the problem. So let's go ahead and take a look at the first thing I want to set up is a number line like we typically will have, and this is all about position. So the position of a particle. Now when we say a particle, it could be anything that is going to be moving back and forth on a number line, and you can think of it like maybe a squirrel that is on a telephone wire and going back and forth. It has to do with, the velocity and acceleration of the squirrel as it goes back and forth, depending on whatever that it does. Okay, and we're going to unfurl that in a moment. Then we need a timeline that starts at 0 that has to do with velocity, and we need a timeline that is going to start at 0 and it has to do with acceleration. Okay, so let's go ahead and start answering these questions the best that we can and put these pieces together such that we can answer all the questions that we need to in regards to particle motion problems. So let's start at number 1 here and see how we do this. Okay, so where does a particle start? And that can be decided that if we look at the position, okay, so we're going to go ahead and take a look at the position function. And so that means is that where on the number line does this particle start? So when something is just starting, we know that the time element has to be 0. And so what we do is that we're going to plug in 0 for the time element of the position, which is right here, okay? And then we're going to see where does this thing start. So I'm going to plug it on in, and we can see when we plug in 0, which again, what that means is that when does the particle start? Time is 0, so where does it start at? That is that when do you click the stopwatch and when does this thing take off. And so it looks like it's going to start at a -10. So what we want to do is that we'll start this particle here at -10, and I'll make my particle red, and let's move on from there. Okay, the next thing that we are asking is that when does the particle stop? And so that when part is very, very important. Where does the particle start is at a -10. But where does the particle stop? That is that this particle could be running back and forth, just like that squirrel on a wire. And where is it going to stop at and maybe turn around? And we can find that out by setting velocity equal to 0. That is that when something has no velocity, that means it's at rest. And so therefore, let's go ahead and do that. So we set this guy right here equal to 0. Oops, didn't mean to. Let me go ahead and fix that. It's supposed to be a subtraction sign. And from here, we go ahead and solve that out, and we see that t is going to equal 1.5. So that means is that after 1.5 seconds, the particle is at rest, okay? And so when we find this out, we want to go to the velocity, and we want to mark that at 1.5 when it's at rest, okay? And so at this point, then, we go to the next question, is that where does the particle stop? So we know where it begins, and after how many, pardon me, after how many minutes that it comes to a stop. So in order to go ahead and do that, find out where it stops, we're going to plug in 1.5 into the position function, and we're going to go ahead and get, looks like we're going to get a -12.5. I just punching in the Desmos quality of life thing. And you can punch into your graphing calculator just the same. It's no big deal. Okay, so moving on over is that how do we interpret that? Is that it looks like its first move here is the particle is going to go over here to a -12.25, and it is going to be at rest here. So the first move is to go to the left, which is interesting. And just like we would think about a squirrel on a wire, or any animal on a wire, that it would go here and maybe turn around, okay? And so, but we have to do more research to, or I should say more calculations to make sure that we're doing this accurately. So let's dig in further. Okay, so the next thing we're going to do is what is the particle moving to the left and the right? So when the particle has a negative velocity, it's going to be moving to the left. And when the particle has positive velocity, it's going to be moving to the right. And when the particle has a 0 velocity, which we've already discovered right here, that means it's not doing anything. So here's the deal, is that if it's not doing anything at 1.5, then it has to be going to the left or to the right over here. And let's see how to test that. So to test whether or not the particle is moving to the left or the right, what we need to do is that we need to plug into the velocity function right here a number that is going to be in between 0 and 1.5. Now, I'm going to do an easy quality of life thing, and I'm going to pick 1 because that number is in between 0 and 1.5. And when I plug that in, it is, we can do a little bit of armchair mathematics with that, is that I plug in a 1 for the velocity here, so I'm going to get 2, right? 2 times 1 minus 3, that's going to give me a -1. And so therefore, this will give me a -1. So I know that the velocity is going to be negative here, and therefore moving to the left. So I'm going to then plug in something that is greater than 1.5, which is, again, quality of life, easy number, a 2. And when I plug that in, I'm going to get 2 times 2, which is 4, minus 3, that's going to give me a +1. And so therefore, It is going to give you a positive 1, and we're just looking at whether the number is going to be positive or negative as a result, okay? We don't actually care what the number is. So like, for example, this could have been a negative 4,000. As long as it's negative, that's all that we're looking at. And this could have been a negative gazillion, or I'm sorry, positive gazillion. And we're just looking whether or not it's going to be positive or not, okay? And so, to go ahead and read this, is that anytime that it is going to be negative, all right, the velocity is negative, it's going to be moving to the left. And so, let's answer this question. Is that the particle is moving to the left from the interval 0 to 1.5, okay, minutes. And it's moving to the right 1.5 to an infinite amount of minutes, okay? So again, let's just take a look. 0 to 1.5, it's moving to the left, which makes sense because we know that the particle is moving to the left in the position here. And it's moving to the right 1.5 all the way to infinity, all right? And so the next thing we need to do is we have to decide when is the particle speeding up or slowing down. So good news is that there's really no calculations to do, is the particle is always having an acceleration of a positive 2. And so if that's true, then all of this is always going to be positive. It's always accelerating in positive direction. So therefore, if we want to go ahead and find out where the particle is speeding up or slowing down, we know that from before. Let's go ahead and review. Is that if it's speeding up, it is going to acceleration and velocity have the same side. If it's slowing down, acceleration and velocity have different signs. And so what we're looking at is the following. Let me go ahead and draw this line here. And so if I look in this area, velocity is negative and acceleration is positive. So therefore, those are competing signs, so I know that acceleration, okay, is going to go ahead, and be slowing down. However, if I look over here, velocity is positive and acceleration is positive, and so therefore I know that the particle is speeding up. So over those intervals, let's go ahead and answer the question. Okay, since, oops, wrong marker. Since it is going to go ahead and these are competing, right, negative and positive over this interval, we know that the particle is going to be slowing down, and I just like to go ahead and put that from 0 to 1.5. And it's going to be speeding up over 1.5 all the way to infinity because all the signs will match. From there on out, they'll all be positive. Okay? And so that's how you answer the questions in a very simple, um, a very basic particle motion problem. So what we're going to do in the next exercise is take a look at when things get a little bit more complex and see where that takes us. So I'll see you in the next video. But before we do that, let's go ahead and finish things off and recap. Okay, is that we went ahead and plugged in 0 into the position function to find out where the particle started. And then we found out when does the particle stop? And we found out after 1.5 minutes, the particle is at rest. It has stopped, okay? And then where does the particle stop? We plugged the 1.5, which was in the previous answer, into the position function, and we got it stopped here. And then we went ahead and we tested points for when is it moving to the left or right. On the velocity timeline, it's moving to the left here and to the right. And so to finish things up, something that I didn't add is that it is going to go ahead and the particle from this point on over is going to be moving to the right from, you know, infinity. And then finally, we looked at the competing velocity and acceleration timelines and found out that it's slowing down over 0 to 1.5 because all of the signs here are competing, and then it's speeding up from 1.5 to infinity. So, just a quick recap I thought I might do, and let's go ahead and see you in the next video.